can't think as people do. The machine is different.
Being! What marvelous being! How gratifying! How gratifying!
I've given many seminars and talks, but I don't think I've ever introduced a movie before. So this is a first for me, but I'm sure for everyone in the audience, this is not a first as far as viewing Jurassic Park. What a treat tonight, and thank you all for coming out, and also Suzanne and Pamela for putting this together. Asked me to tell you a little bit about cloning, and the professor in me is going to ask the first question. So you heard that I cloned the first rabbit. That was when I was in graduate school in the University of Massachusetts. Anybody have a good idea why you would clone a rabbit? All right, good.
For reproducible results when testing bioactive chemicals?
All right. Well, so the answer is that's a good one, but I don't really know a good reason. And if you come up with a good reason, please let me know. But that's one good reason right there. But we did clone the first rabbit back at that time. As I mentioned, I was in graduate school. My wife Tracy, who's here as well. We were expecting twins at that time, and so I did get accused of taking my work home with me at night. But luckily they're great kids. One's doing her PhD, finished her PhD, and now is doing a postdoctoral fellowship, and the other one's making wine. So they're doing great. But anyway, my best reason and reasoning for not cloning humans is that I love my kids very much, but I wouldn't want another one of either one of them. So that's the answer for cloning of rabbits. We did go on and clone the first cattle when I was in first cow and shortly after Dolly. So tell me again, ask the questions of you. Well, what was the first cloned animal? Did I give away the answer there? Sheep, Dolly, the sheep. Well, you'd think that, but not really. There were cloned frogs back in the 1950s, and there was a guy named John Gurdon who was cloning frogs back in the 1960s and 70s. And does that ring a bell for anybody? John Gurdon? He just in 2012 won the Nobel Prize in Medicine and Physiology for some of those discoveries. But Dolly the sheep was the first cloned of an adult animal, and we shortly followed that up with first cloned cattle that came after Dolly. Sheep have a gestation length or pregnancy length of about 5 months. Cattle have about 9 months. We were approximately 6 or 7 months behind Dolly, so it's interesting how we all work in the same area, and they're first by a couple months there. But that was fine. We got on the front page of the New York Times and the first story on CBS News, and we got a lot of press for that. And then it all stopped about 2 days later. We were invited to be on Face the Nation, myself and my co-inventor, co-conspirator in cloning, but it all stopped. And anybody know what happened in 1998 that this happened? No, not the Challenger. Monica Lewinsky. So timing is everything. And, but we got our 3 days, 2 or 3 days of fame when we did that. So it was great, and we've been doing work in the area since then. Let's see, well, what else can I tell you? I think the movie was, what was it? It was, anybody know, what year was?
93.
93, right. And there were cloned animals just before that, and I can certainly, we can talk about cloning technology till into the evening, but I don't want to do that, so go ahead.
So I get to ask the first question.
Okay.
Yeah, that mic doesn't.
I could probably speak loudly
All
enough
right,
that
no.
you could all hear.
No, I bet, well, I'll just hand it back.
Or
All right.
it's being recorded.
So when were you first interested in cloning? Did you grow up on a farm?
I did grow up on a farm, and we had sheep and we had cattle. Did you know that? Yeah. But I thought I wanted to be a veterinarian until I learned how hard it was to be a veterinarian, how much hard work they had and how difficult it was. So I decided to be a scientist. But we were actually trying, what really turned me on to this area was in college that we made sheep and goat hybrid, or a chimera. Everybody know what a chimera is? No. No? It's a mixture of two animals. So a sheep and a goat together, what would you call that? Shoat. Or a geek. Yep, you got it, exactly. So that's when I first got interested in that.
So I think we'll open it up for Q&A, and
Good.
if you wouldn't mind just speaking really loudly, so Steve can answer the question, or we
Sure,
can repeat it to
sure,
Steve.
happy to.
Thank you.
You had a question right there.
How many tries did it take to get your first
Cloned animal?
clone?
How many times did it take to try? That's a very good question. Dolly the sheep, I think, took 278 tries. I think we did it in about 200 tries. That was about. But it took a lot of work to do it, and a lot of people worked very hard at it. So I wasn't the only one that did it.
She posed my question.
Oh, good.
Yeah.
So it was an attempt. So I'll ask the question: how did Dolly get her name? Yes.
I believe because they took the cells from the sheep's mammary glands, and Dolly Parton has large mammary glands.
Yeah. I think the farmhands were waiting for Dolly to be born. They were doing a midnight shift, and they were saying, "What should we call this animal?" But the cells that were cloned, used to clone Dolly, came from the mammary tissue of another sheep. Why did they use that? Well, there was a lactation physiology lab that was, milking physiology lab that was next door, and they donated some cells. Basically, the thought was at that time, you can't clone an adult animal. So basically, Dolly was what we call a negative control, where you take something and you know that it won't work. Well, lo and behold, it worked in that instance, and for us as well. Yeah, question.
So what makes it successful?
Uh,
Like, they just survive?
Yeah, that is a great question. And if you can answer that question, you'll get a Nobel Prize. But really, we don't know. Still to date. I mean, it's gotten better as far as efficiency and how well people are able to clone animals, but it's still not very well known why it's inefficient. Yeah. Good question. Yes.
Do you think that there will be a time that we can clone, say, people, but have them, say, not have a brain, so we could steal parts as like?
Yes. I think you were in the audience about 20 years ago when I gave a talk on this topic. But I actually went to a society out in California to give a talk, and they actually were promoting that idea that maybe we can clone people, take out the higher brain centers, and then we just hold them back for organs
Yeah.
for transplantation.
So I read recently that we just recently found our first prehistoric blood
Yeah.
samples.
Okay.
So given that we're going to be watching Jurassic Park, can we
Can we do it now?
Can we do it?
Yeah. And well, you never want to say never, because there's a guy that said you could never clone an adult mammal, and lo and behold, he's still eating his words to date. But I mean, there are people that are interested in that. I think before you do that, I mean, if you're thinking about endangered species, one of the companies that I helped start out up in Massachusetts actually cloned an animal, a gaur, and that's an endangered species in Asia. And I think that's quite possible. So thinking about prehistoric animals, maybe a saber-toothed tiger, I think is quite possible. A woolly mammoth might be possible. You might think of how you'd clone a woolly mammoth, knowing what you know about Jurassic Park. You might take an elephant egg, right?
Sure.
Use an elephant egg, yeah. Have you ever seen how they collect elephant eggs? I have, and it's not a pretty sight.
What diseases will regenerative medicine be the most useful?
Yeah, and it's a good question of where the first impact. I mean, if I predict, and my prediction is correct, we'll be doing all kinds of things from diabetes to other areas. And actually, right now there is a clinical trial, and one of the companies we helped start here in Georgia is playing a role in that for type 1 diabetes, using stem cells as a source to make insulin-producing beta cells. So I think that's quite possible, and it'll take a while, but we'll get there eventually. Macular degeneration is another area that I think will have one of the most dramatic impacts first. But we're right now working in the area of stroke. We think that we can actually repair the brain using stem cells that we've developed and products of our stem cells. So I think there's but you name it, anything that's degenerative, I think is wide open.
How about regrowing an arm or something? Is that possible?
Yeah. You know, if you could study how frogs and newts and how they regenerate limbs, and there are developmental biologists that are studying that and how you could do that. But I mean, it's serious business for the military and helping war fighters that have problems. But yeah, there's a lot of things that if you think about it, there'd be a lot of cool things that you could do in the future. One other thing we need to do. Good.
One last question, Bernie, or?
I hate to get into the ethics of it. You keep kind of mentioning that. With you being such a public figure, I think about this movie we've got from like Malcolm, the guy that's kind of the naysayer about the whole situation.
Yeah.
If you, not to get specific, but I was just curious if you met any pushback from any like groups that are just sort of really
good question,
not favoring that.
You know, I have, and one of the most rewarding things for me is to go in front of a group that may have questions and very good questions about the ethics side of things. And I'm not there to really change anybody's mind, but if I can give them a better understanding of why we're doing what we're doing. For instance, Suzanne said that we were able to make stem cells out of non-viable embryos, or ones that were being disposed of. Well, you know, that I really don't understand that, but really I make the analogy to organ donation. So the embryo is not viable enough to produce another individual. Why shouldn't we be donating that embryo, like a lung or a kidney or a heart, that might help somebody else in the future?